Good evening, guys. Good to have you back. Today I want to teach you how to write an equation for a relation. When given the slope and the y-intercept, backwards from what we've been doing before, I've always given you the equation, we made the graph, or we made the ordered pairs. I'm going to go this way today. Write the equation. So make that the title on the next free page in that math notebook. Once you've done that, mark that page, close it up, turn everything off, clear out those distractions, and here we go. So we've been looking at equations in this slope-intercept form. Super nice. When it's written in this form where y equals, so we've got the output like all by itself in the equation, and it's written in this kind. We know that this is going to be the slope, the coefficient of x. And we know that this, the constant, add the opposite, it's called the constant, is going to be the y-intercept. We've been looking at that for a couple of days. Yeah, it's called slope-intercept. Form of the equation tells you the slope and the y-intercept really easy. And knowing that, we've always taken an equation and written a graph. And today I want to talk about writing an equation. We've never done that before. So if we know this slope, how this slope-intercept form here works, I'm going to kind of declutter it a little bit. It's going to be a big help. If we know we can look at equation and say, okay, slope goes here, y-intercept goes here, we can write the equations pretty easy. So what I want to do today is we're going to take a description or ordered pairs or something, and we're going to actually write the equation from that. So I've got kind of a level 1, a level 2, a level 3. So level 1 is I'm just going to say, what's the equation for a relationship with a y-intercept of -6? I'm just going to tell you the y-intercept and a slope of 2. I'm just going to tell you the slope, and that's it. So what we can do if we use that slope-intercept form, I know the equation gets written like this. It's y equals something times x, and that's the slope, plus something, and that's the y-intercept. It might be minus if it's negative, or we can do plus negative, either one. If I know the y-intercept and the slope, I can just kind of fill in the blanks with that form and be done. I can write it in that slope-intercept form and hardly have to know a thing. And that's what I'm going to do. I'm going to say it tells me right here the slope is 2. The y-intercept is -6, so I can write it like that. Plus -6 is the y-intercept. If you insist on subtracting, you can also write it like that. Those are the same. And either of those are the equation. That's it. If you know the slope and you know the y-intercept, you can write it in slope-intercept form. And that's it. Kind of nice. That's kind of like a level 1. Here's like a level 2. This one, instead of just saying, hey, here's the slope, hey, here's the y-intercept, check out how it looks. It says Tom's job is 24 miles from home, and he drives back at a speed of 1 mile per minute. So this doesn't say the word slope, and this doesn't say the word y-intercept or initial value, but they're in there, right? 24 miles from home, that's where he starts. Like we made the graph up here. There's no 24 on there. Wherever 24 was, that's where he'd start, and it looks like he's going back toward home. So we're going to have a graph that looks something like that, right? So that is where he starts, and in a situation like this, the starting value, we often call that the initial value. That is the y-intercept. It's in the equation right there. Drives back at a speed of 1 mile per minute. That sounds like a slope. He's driving back at a speed of 1 mile per minute. That is unit rate language. And remember, unit rates and slopes refer to the same thing. So that sounds like a slope. He is coming home. So the slope's going to be negative in this case because he's coming back. It's a downhill graph. He's coming back at 1 mile per minute, but that's it. So I can just write my equation, y equals blank times x. That's going to be the slope. Plus this, that's going to be the y-intercept. And I really do have them in the situation as long as I know what means what. The y-intercept is 24. And the slope is -1 in this case. -1x is the slope. Right, like that. It's also okay if you reverse them. If you say he's going to start at 24 and then do -1x. That's okay too. It's all right if the slope and the y-intercept are reversed. You're adding, doesn't make a difference what order you do it in. Either of those would be correct. That's kind of like a level 2. It doesn't say slope, it doesn't say y-intercept, but really they're there if you know how to read a verbal description. Level 3 might be something like this from ordered pairs. What I'd like to do is write this in slope-intercept form, y equals something times x, that's the slope, plus something, that's the y-intercept, that constant value. But I don't have either of them. Sort of. I actually do have the y-intercept in that table. It doesn't say the word y-intercept by it, but it is actually there. It's this point right here. If you think about that point on the graph, x equals 0. So I go 0 here, y negative 1. That point would be right there. That is actually my y-intercept. I have to know a little bit. I have to kind of check it on the graph to make sure I put the right one in the right spot. But I actually do have a y-intercept of negative 1 that I can plug in. So it's not staring you right in the face and saying, hey, here's the y-intercept like the last two were. But you can find it. Slope. Don't have the slope, but we worked a long time on finding slope. You know how to find a slope from a table. I just have to do it. So in this case, each time x goes up by 1, y goes up by 3. X goes up by 1, y goes up by 3. X goes up by 1, y goes up by 3, and so on. So my slope then is 3, and I can just put that here. And so y equals 3x plus negative 1, or y equals 3x minus 1. Same thing. Add the opposite. Either would be fine. So hopefully not too bad. Take different things we're given and use those to write the equation. Let's do 3 together. If you'll open up your math notebook, we'll do a level 1, a level 2, and a level 3. If you want to split up your paper like this, you really won't need the graph at all, except maybe a little bit on the level 3 one. So if you don't want to draw the graph, no big deal. If you just want to quarter your paper and write this here, and that will be fine. So what's the equation for a relationship with a y-intercept of negative 1 and a slope of 4? This is level 1 because it tells us what we need here, and it tells us what we need here. It's very straightforward. I want to write this equation in slope-intercept form. So I want to write y equals slope times x plus y-intercept. And they're both given to me. I just have to plop them in where they go. Slope of 4 goes here. Y-intercept of negative 1 goes here. I prefer to write my slope-intercept with addition always, because I know, add the opposite, but you can write it as this as well. Remember, anytime I see subtraction now, just about always, just to avoid any confusion, I add the opposite. Same thing. That's what I prefer. Up to you. So that's like a level 1, like very, very in your face. Here's the y-intercept, here's the slope, put them where they go. You got your equation. Level 2s, as I like to call them, are realistic situations where we've got something happening and it doesn't say the word slope and it doesn't say the word y-intercept, but they're actually in there. So as I look here, Loganville taxi service charges $10 to pick you up, then $3 per mile. This was a very common situation back when we weren't doing abstract, right? There's some charge to start and then some charge per mile. So I see my unit rate language here, $3 per mile. So that is my slope. And then $10 to pick you up. So that's like, even if you don't go any miles, like just to show up, $10. We call that an initial value in a real equation, in a real situation, which turns out to be the y-intercept. Like on the graph, it would start up here at 10 and the price would increase from there. Like even at 0 hours, it would be $10 to start, and then each hour it would go up $3, something like that. So we get a graph that looked kind of like that. And that would be the y-intercept. It would intercept, it would start on the y-axis at 10. So let me just plop it in. Y equals slope times x plus y-intercept. There's my slope, 3. Should be positive. This is an increasing situation. The price goes up, increasing. And $10 to pick you up. Got it. If you wanted, sometimes with realistic ones, I like to use better variables than X and Y. Like I might do miles and charges or miles and costs. So I might do cost equals 3 times miles plus 10. That's okay too. And remember I said also, since the 10 comes first in the problem, if you want to reverse those and do cost equals 10 plus 3m, all those are okay. Those are all the same. Doesn't matter what order. Still slope-intercept form. Okay. Level 3s are what if I give you ordered pairs and ask you to write the equation from that. I want to write that equation in slope-intercept form, but, which is going to be y equals blank times x plus blank, where that's the slope, and that's the y-intercept. But I don't have the slope, and I don't have the y-intercept. Neither one. Well, kind of. First thing to notice is you actually do often have the y-intercept. It's not always in the chart if you don't choose x equals 0. You know, when x equals 0 means we're not going to move on the x-axis. We're just going to go up and down, and that's where your y-intercept's going to be. But I always choose 0 as one of mine, and so I always end up with my y-intercept just staring me right in the face. That 0, 2 is going to be right there, and wherever my graph goes from there, I know that that's the y-intercept right there on my graph. So that I can just put in, y-intercept of 2. Slope I have to figure out. So the way I choose my numbers, -2, -1, 0, 1, 2, that always ensures I can use the x goes up by 1 strategy. You don't have to. You can use the other strategy with the easy ordered pairs, but you can use that one. So here, x goes up by 1, y goes down by a half. X goes up by 1, y goes down by a half. X goes up by 1, y goes down by a half. So that's my slope. Negative. You can do negative 0.5, or you can do negative 1/2 x, out of space, plus 2 also. Y'all, that's how you write an equation from either ordered pairs or a verbal description. I hope that makes a lot of sense. That slope-intercept form, boy, does that make that quick and easy sometimes. And I sure hope it did for you today. If it did not, please give this another go. Watch it again. Pay extra close attention, and I know you'll pick it up and you'll feel super confident when you get here tomorrow. See ya.